interesting to know how they've started their journey. Okay, so let's start with our NSX Tech Day. Okay. Okay, let me introduce myself. My name is Arpita Mahajan. I am currently working in Sungard as a VMware specialist. And, to start with, NSX has always been a buzzword around, and while working, I've always been curious that why everyone is moving to NSX. I don't know. I mean, everyone, like, even they don't know, they have their NSX installed in their environments. So even, my colleagues, my customers here in Sungard, and even when I was working in VMware, so many customers asked me, what is NSX and why it benefits us? Like, what's the why it's actually required in our environment? So, and I think most of you have also given some thought to it. So this presentation right now here is, it will try to give you an overview of NSX, and and it will maybe hopefully by the end of this session you'll have a idea, or maybe the word NSX will start making more sense to you. Okay, so let's start. Okay, so as I stated, we'll be covering why and what of NSX, and if time permits, we'll try to cover how it is integrated with our vCenter, because as a vSphere admin, I need to know how it is done that, and we'll get to know, a brief introduction to what are the new products in NSX. Okay. Yeah. So the first question is, why NSX? Okay. So as far as traditional networking is concerned, and as Nitesh already told, that there are so many limitations that we don't actually realize. Like, on top of my head, I have this, if you want to change a VLAN setting, you'll have to do it like throughout your network infrastructure, like including every network layer. So maybe network admins can relate to me. The secondly, you have a VLAN limitation, which is you can only assign 4094 VLAN IDs. Although this number look quite sufficient for enterprise deployments, but it's actually becoming a bottleneck for the cloud providers. And as Nitesh mentioned, that the security part, that as these cloud management providers are coming into the picture, the security for each workload is becoming a major concern right now. I think you agree with me, right? Okay, so let's look at the slides as well. So these are some of the common challenges that we face with traditional networking. We have complex provisioning, limited mobility. You have performance choke points due to hairpinning. So we'll come on to that in a second. And you have increase in east-west traffic. Okay, so those who are not network admins here, let me tell you what east-west traffic means. So east-west traffic is server-to-server traffic within the data center. While in contrast, you have north-south traffic, which is client-to-server communication, or client-to-server communication between the data center or a location outside the data center, right? Now, you have some more challenges, as several security blind spots. Then you have lack of seamless integration with the applications. So let's see how NSX has optimized all of these. Okay. Okay. I know there's a big term here, but since NSX is involved, I need to explain what is all this. So VXLAN. Let me explain you what VXLAN is. So VXLAN is virtual extensible LAN, and it's an overlay network technology. Now, when you say overlay network, what it means? Overlay network means that you can create any logical network on top of your physical network, existing physical network. So if you see here, is this working? Yeah. No, it's not showing up here. Oh, I'm so sorry. Okay, so as you can see here, this original Ethernet frame is been encapsulated with your all these headers, VXLAN, UDP, IP, and then Ethernet headers, and then it's the whole packet is encapsulated and then transmitted across your network infrastructure between the tunnel points. Now, what are tunnel points? So these are VXLAN tunnel endpoints, and those are basically your ESXi hosts. So it's just this. This is how the encapsulation is done with the help of VXLAN. So this NSX, the best part is still remaining. The best part is that it actually removes the limitations of your 4094 VLANs. It gives you the limit of 4094 to, it actually extends that limit to 16 million new segments. I know that's a huge number, but it's actually good for very like bigger cloud platforms. And how it is done that? So because of this guy, if you see, this is VXLAN segment identifier. This is VNI, or you can say VXLAN network identifier. This 24-bit identifier is associated with each L2 packet, and it is actually associated with each L2 packet, which is created in a logical space, and then it is passed through a L3 network. So why we are doing all these things? So that your L2 packet can actually move over your L3 packet without noticing that it is a L2 packet. Amazing, right? So this is just one of the benefits. Let me go for the next, which is distributed routing. Okay, let me explain you with this example. So as you can see, if I consider a network where NSX is not installed, okay, you have two VMs which are on different networks, but are on same ESXi host, and if they want to communicate with each other, how the traffic flows? The VM has to, from here, the traffic has to go to the ESXi host, then it has to touch the physical layer, and then it has again come back to the same ESXi host, and then to the VM2. Am I right? And all this communication, it's taking 6 wire hops only for just one communication, right? But in NSX, what has been done? Okay, so routing functions are integrated with switching functions inside the hypervisor itself. Okay, that actually gives you direct one hop communication between the VMs, or you can say it gives you direct one hop communication for your east-west traffic. As you can see in the another scenario where two VMs are on different ESXi hosts, different networks, again the traffic has to touch the physical layer and it will come back again to the same logical space. But with the help of NSX, or you can say with the help of distributed routing, the traffic will never leave the host. That's the beauty of distributed routing. It will never. So it actually resolves this problem, plus it actually resolves the problem of your traffic hairpinning. Now, seems a very fancy word, traffic hairpinning, but let me explain you, it's very easy. Hairpinning, if you see this, see this diagram, and if you see the flow of the traffic, this traffic is actually creating a fold like a hairpin over there. Okay, and that's why it's called as traffic hairpinning, because traffic coming in and going out of the same interface, it creates a fold and it actually creates lots of blind spots. So that's when it, and clearly NSX is not doing that and it's clearly avoiding it. So it resolves that. Okay, moving on to next. If you guys have any questions, you can ask me in between. Okay. Yeah. Sorry? Yes. So actually, yeah, north-south is only for your outside your data center. So east-west is a server-to-server traffic. You can call it as
same VLAN.
Same VLAN, but in different networks.
Segment.
Yeah. It was very difficult. Okay. Thank you. Any more questions? Okay. We'll start with distributed firewalling. Okay. So let me consider so how traditional networks with distributed with respect to firewall currently working as of now. So traditional network doesn't have any system. Is there anything? Sorry. Okay. Okay. So the traditional networks doesn't have any system right now where server-to-server traffic can be inspected by security rules. You must have seen that the perimeter firewall is there. You have a central firewall. But what about the traffic inside the data center? Have you seen any security rules for within the data center? I don't think so. Okay. But with NSX, with the help of distributed firewalling, you can now enforce firewall rules for each and every VM of the environment on per VNIC basis. Okay. So as you can see in this diagram, this VM has to go, or this, if he wants to gain access or gain access to this particular VM, the traffic has to flow all the way up to the perimeter firewall, then come back, and then go to the same ESXi host, then come back to the same VM. So it's like just it's unnecessary traffic. Okay. Now with the help of NSX, it's just that the traffic is inspected right here at the ESXi level. It will not go to all the way up to the perimeter firewall. This resolves your performance choke points. It resolves your security blind spots. There's so many other things. So it's exactly the same. Again, the traffic will be inspected at the ESXi level. It will not touch the physical perimeter firewall. Although you may need perimeter firewall for your north-south traffic, but for server-to-server traffic, you can actually install, or you can have your distributed firewall over here. Okay, am I good? Okay, so there are so many other benefits of NSX, like NSX can run on any hypervisor. NSX can run on any network hardware. NSX can be integrated with any cloud management platform. And plus you don't even have to change the underlying physical network. This is the beauty of NSX. There are so many other benefits, like it's cost effective, it's scalable, it's easily monitored, and it's easily provisioned. So network provisioning, which used to take days or weeks, now it can be done in seconds. Now, and I can't even name all the benefits of NSX over here because there's so many. But in all, if you want to conclude, you can say that a network hypervisor can handle layer 2 to layer 7 services like switching, routing, firewalling, load balancing, VPN, all in one software, right? So that actually brings us to what is NSX. So NSX is VMware's software-defined network solution. It's actually transforming your data center network model exactly like server virtualizations did several years ago, right? And you can say that the NSX was the missing piece of your software-defined data center. Okay, so it has tons of components. We'll be taking a look, but before going on to the components, we'll be taking a look on the architecture. Okay, I think you have who has seen this architecture? Okay, quite few. Okay, so this is the very basic architecture, and it's, I think, all over the place. But it has 3 planes. NSX has 3 planes: data, control, and management. Your management plane has your NSX manager. Your NSX manager is mapped to your vCenter. Then in the control plane, you have your NSX controller cluster and your DLR control VM. And in data plane, you have 4 components, which are logical switches, distributed logical router, then you have distributed firewall, and then you have NSX edge. Okay, so let me tell you, each component in itself is a very huge topic to discuss. This is really big topic to discuss, but since I am covering an overview, so let me give you a brief introduction to all the components one by one. Okay. Well, I understand this is a lot to take in one go, but all I want is that at least you guys be familiar with the NSX terms, and maybe when you start your NSX journey, you'll remember me. Okay, so NSX components. So I'll start with data plane first. Now, why data plane? Data plane is the one where all the VM traffic flows, your actual traffic flows. Okay, so it has 4 components, which the first one is logical switch. With the help of logical switch, you can actually reduce, or you get the direct one-hop connectivity for your east-west traffic, which I just discussed. Then you have your distributed logical router, which is sorry, I may have given a different order, but let me discuss. Okay, so then the second one is distributed logical router. It actually gives you it actually reduces your east-west traffic, and then it solves the problem of your traffic hairpinning. Then you have distributed firewall. Again, this is it. With the help of it, you can enforce firewall rules on each and every VM of the environment, and on the VNIC basis, on the per VNIC basis. And distributed logical router and distributed firewall, these two particular are installed on the hypervisor itself using VIBs. Okay, and the last one, NSX edge, that I haven't touched till now. So NSX edge is the one, it provides critical network services, especially for the traffic which is coming in or going out of the data center. Okay, so it's around the perimeter. So it gives you services like load balancing, it gives you perimeter firewall, it gives you perimeter routing, it gives you user and site VPNs, DHCP, DNS, IP services, NAT services, all this only one component. So if you combine all of these, all the components in the data plane, you'll see that it's actually the VM traffic, it's actually switched through logical switch, then it actually routed through distributed logical router, then it passes through distributed firewall to the destination. And if the traffic is bound for an external network, then it will pass through NSX edge. So it means that if any component in data plane fails, that means it will have a great impact on your network services. Your network will be down. Okay, moving on to next, we have control plane. Now control plane has VM traffic doesn't flow from control plane. So if any component fails here, it doesn't impact your services. Your environment will still be running. It just handles some things. So it has 2 components. The first one is NSX controller cluster. So NSX controller actually handles your hypervisors, switching and routing controls. Basically, this guy handles your logical switches and logical routers. That's it. And it's always deployed in a form of cluster of 3. Why? Because it's a high availability that VMware recommends, and anyways, if it can have at least one failure. So with the help of 3 clusters, you can have a 1 failure in it. Okay, and your routing and switching will still be continuing. So it doesn't matter that even if the NSX controller goes down, your environment or your network traffic will still be flowing. Then the second one is DLR control VM. Small component, but still very essential part. it actually learns the routes from your NSX edge, and then it pushes it to your ESXi host via NSX controller. So the routing information from your NSX edge to your hypervisor, and from your hypervisor you get it to distributed logical router, and that's when the routing information exchange takes place. Okay, and the last one is management plane. And if you see, if I can actually go to the architecture, that would be good to explain. Okay, yeah. So if you can see in the management plane, you have NSX manager. As you can say that the NSX manager is the heart of the NSX. It's like it's centrally managing all the NSX components and their configurations. And so NSX manager also act as an entry point for the REST APIs. So REST APIs, that means if you see the cloud consumption plane, the VRA, vCloud Director, OpenStack, if they want to leverage NSX services, this is how they do it. They do it through NSX Manager. And that's why NSX Manager is the entry point for your REST APIs. It has one-to-one mapping with the vCenter. That means only no two vCenters can be mapped to one NSX manager. It has only one-to-one mapping with the vCenter, and it is deployed as a virtual appliance. So this virtual appliance then connect with NSX controller through NSX APIs. So this is a brief introduction. I know this is too much at this point, but I know at least when you start going through the actual architecture, NSX architecture design guide, you'll get to know what I was saying. So at least you will get a start for your NSX journey. My main presentation is just, this presentation is actually for your head start to your NSX journey. Okay, so this is just an overview. I cannot actually take in or maybe go in a deep dive into it, but maybe next VMUG we can have it. Okay, so this was all about NSX architecture. Now we, as a vSphere admin, I have this doubt that how can I integrate my vSphere environment with my NSX environment? How do I do that? So I just said that you deploy your NSX manager as a vSphere, as a virtual appliance. So just open the GUI of NSX manager, and yeah, on the home page itself, you see that manage vCenter registration. That's it. I think you just have to give the vCenter details over there, map your vCenter to the NSX manager, and yeah, you can use your NSX, and you can integrate your NSX environment with your vSphere environment. That's it. That's how easy it is. Obviously, there are tons of things which are going around at the back end, but yeah, it's just an overview. If you want to just administer as an administrator, if you want to look on how this is done, this is how it is. Okay. Now let's look on what are the new products of NSX. So this was all that we have just checked. That was NSX for vSphere, and it is abbreviated as NSX-V. Now we have one more product as NSX-T, and I think Nitesh has said that the T stands for transformers. So NSX-V is only for your vSphere environment, but NSX-T is not only for your vSphere environment, it's also for your OpenStack, your Kubernetes, Docker, as well as Azure, AWS. All these things, I think NSX-T is used. Then we have one more interesting product which is called as Cross vCenter NSX, which is nothing but it's like centrally managing your network virtualization services with with multiple vCenters. So each vCenter will have its own NSX manager, and they'll be centrally managed, being as primary, secondary, and all. That's how the base is the NSX. Obviously, you can have multiple products on top of it. Then you have NSX Cloud. This is the, I think, most hot product in the market right now. So this product has been introduced in VMworld 2017, but since then it has been much improvised. It actually gives you, or it actually provides networking and security services to the applications which are running natively in public clouds like your AWS or Azure. So yeah, I think that's all from my end. Um, yep. This was like a quick overview of NSX. I understand that most of you, maybe they haven't started their journey with the NSX. So maybe it will give you a head start, and hopefully maybe you can start administrating the NSX environment as well after this.
Some of us, I think, here will start their journey with HOL. Right? Many,
Yeah,
I think.
you have NSXT and